So next we are looking at the same magnet, bar magnet. That's your axial line. This is your equator. So we are taking up a equatorial point, a point on the equator basically. So what happens if I keep an imaginary north pole over the monopole? So we have it to get pushed and another will get pulled. Now the question is, what is the net force at that point? Quite simple. All we have to do is resolve it. One can be along the perpendicular line, perpendicular to your, magnetic dipole, and parallel to that. It's always that. It's with respect to dipole. That's why we define dipole. And so this is parallel to anti-parallel in some sense. But yeah, Panda is this. And this is perpendicular. And we need an angle. So the reference line is again M. So the angle will be over here. As simple as that. So this is going to be equal to this because they are. Think of it. Why is that? Let me show it off. One quick glance. We have one parallel line, another parallel line. This is your transversal line. So this angle is equal to this angle. Next, we have to look into the angle of the other north pole's force as well. So how will we relate that? We have to make use of this. So this is your 90 minus theta. This is 90 degree. This is theta. This is 90 minus theta. So this is also 90 minus theta. And this will be what? This is perpendicular. So this has to be theta. Okay, guys. So let's look at the actual derivation. It's quite simple. If you have done this, I don't know how many times by now. Similar ones, that is. So this is S, this is N. So that's your direction of dipole. Say this is O, this is P. This is generally L. This is generally R. In our case, we taken it as R. And we'll take this as, say, some D. So this also will be D. So this is theta and this is theta. Again, just stick to one reference line and the formula will reflect that. Okay, so end of it, you can take this as also theta. You'll get the same answer, to be honest. So don't be worried about which should be theta. Anything is okay. Next thing is, let's move forward in resolving them. At least drawing the aspect. So it has to be resolved parallel and perpendicular to your axis. So this is your north. That's your south. This is along the equator. This is along the along the axis parallel to your magnetic moment. So I'll keep it along, x and y axis and stuff. So it makes it convenient for me. So what I'm indicating here is to the left is positive x axis, up is positive y axis. Okay, guys. So that's our Fn. This will be Fn. This is theta. This is theta. So this is sine theta, or this is sine theta. Yeah. Opposite side, right? And we have a down force. I didn't mention that. So this will be S sine theta. This being Fs. And along your positive stuff, we have Fn cos theta and Fs cos theta. And so on and so forth. Right? So this is basically it. If you're able to figure out this diagram, you're pretty much done. Try doing that on your own, and rest of it is a bit of math and you're done. So what is that we are looking at? We are looking at magnetic field due to each point. So we have at P mu naught by 4 pi qm by d square. So let's not talk about the direction. Here we have mu naught by 4 pi qm by d square. To figure out the net force, we have to resolving perpendicular and parallel to B. So we'll consider, I have not written this, magnet along x-axis. It makes it easier to discuss further. So Fn perpendicular component will be perpendicular to B. Remember, it's along the y-axis, so it would be mu naught by 4 pi qm by d square. And as per your vectors trigonometry, this will be sine of theta. So it is reduced by a factor of sine of theta. This is along positive y-axis, right? Or let me write this, actually, this is too much to write. Let me reduce it for you guys. This is Fn sine theta. While your Fn, or let me do Fs perpendicular, so you can see that they are opposite. So this is positive and this is negative, sine theta j cap. And Fn and Fs are equal in terms of magnitude, as you can see. So these two will cancel. While your Fn parallel will be minus because it's to the left, and this is cos of theta. See, it's very simple. If you can put it in your head, imagine in your head, this is straightforward. Fs parallel also is the same stuff, actually. I cap. So clearly, from all the above equations, right, including on my screen the left part also, Fn and Fs expression, Fn perpendicular, the perpendicular component will get cancelled. Let me write that. Perpendicular component cancels each other. So with that out of the way, let's move on to the net field at point P will be equal to your minus Fs cos theta I cap and minus Fn cos theta I cap. So these are one and the same. This is nothing but minus 2 mu naught by 4 pi qm by d square cos theta I cap. Of course, our final answer has to be in terms of what? It has to be in terms of L, R, and M, not even theta. So let's substitute one at a time. First, we'll substitute cos theta. Cos theta is adjacent L by D. It's L by D. Agree? So this will be L by D. So this will be minus 2 mu naught by 4 pi. 2 we'll keep it. You will see why. Qm by D square L by D. Next, we'll substitute. Oh, this is on. This is because cos theta is L by D. Next, let's substitute D. Let's substitute of D square, which is equal to L square plus R square. And here it is D cube. So this will be, B will be equal to minus 2 mu naught by 4 pi QML by R square plus L square to the power of 1.5. Next, we have substituting finally our dipole moment. So M, which is equal to 2LQM. In our case, it is I cap, in the direction of I cap. Oh yeah, by the way, I forgot. I cap. So it's I cap, right? It's from left to right. Agree? So since it's from left to right, it is I cap. This is minus 2 we are picking up. So minus 2 QML. Just remember the standard things, whatever you have, like the distance and dipole moment, it has to be expressed in that manner. So you just keep that in mind and you are pretty much done. So this will be R square plus L square 1.5. So you don't have to memorize everything. Don't memorize everything. No point. Don't memorize each step. Just have the common sense, a few bit of facts. And always remember they will be expressed in standard form being the distance from the origin. Sorry, not in this case origin. From O. And it will be in terms of L, R, and M. So with all of those in mind, you just substitute and you will get the final answer. The intermediate expressions are quite simple again. They are just basically vectors. To get these vectors, you have to be strong with your drawing diagram. And that's very simple. Just draw a simple diagram. See if it's a push or pull. Imagine that there's a unit North Pole and figure things out from there. That's it. Is it not, guys? So now pause and have a look.